On today's episode of the On.NET Show, we're going to be talking with Brigit about .NET for Apache Spark and how to crunch petabytes of data with C# and F#. Check it out. Hey, welcome to another episode of the On.NET Show. Today we're going to be talking with Brigit about .NET for Apache Spark. So, Brigit, thanks for being on the show. And how about you introduce yourself and tell us a little bit about Apache Spark and how you can use .NET with it.
Sure. So my name is Brigit Murtaugh, and I'm a program manager on the .NET team here at Microsoft. This is actually my first episode of On.NET, so I'm really excited to be here. And .NET for Apache Spark brings the awesome world of big data analytics to the .NET ecosystem. So today we'll be talking about what Apache Spark is and how you can get started with big data as a .NET developer today.
Cool. So yeah, just start telling us about it.
Sure. So Apache Spark is defined as a distributed engine for processing huge quantities of data, anywhere from terabytes to petabytes of data. So for example, you could think of if you had a huge factory with thousands of IoT or Internet of Things sensors, and each of those sensors could be producing petabytes of data every day. And while it's awesome to have that much data, so we can understand how our factory is running and if there's some sort of malfunction in the equipment, it can be really challenging to actually process all of that data in a quick and easy to understand way. So we have an awesome tool known as Apache Spark, which allows us to analyze anywhere from small to huge quantities of data using some really easy to understand APIs. So it's really user friendly.
Makes sense. And how is it similar to, say, Hadoop? Hadoop is another Apache project that seems to be a big data. So how are they similar and different?
Sure. So Hadoop MapReduce is a really popular solution or algorithm for big data processing as well. But you can think of Apache Spark as the next generation of big data processing. So Hadoop MapReduce came first, and it is on disk. It does its computations on disk, whereas Apache Spark is in memory. So the in-memory power of Spark can be up to 100 times faster than Hadoop MapReduce, which is pretty awesome.
I see. So are most people that you would talk to today moving to Apache Spark or have already done so?
Yeah, I would say the trend of the industry is definitely that Apache Spark is the way to go with big data analytics.
Okay, and are you seeing adoption like clustered that, say banking has gone already, or like where do you see the biggest use of Apache Spark, or is it just kind of across the board?
I think it's definitely across the board. We've talked to quite a few different customers who have been interested in it, and it can be anywhere from large enterprises to even just students or people at universities trying to learn and process some sort of interesting information using big data.
Makes sense. So let's say you're not using .NET. What are the most likely programming languages that you would be using for Apache Spark before we talk about the .NET part of it?
Sure. So some of the most popular languages are Scala. That is what Spark is natively written in. And then also Java, Python, even R as well.
Okay. So then I guess what is the reason why we did this project? Were there people asking us to support, say, C# or F# with it? How did we end up doing this project in the first place?
Yeah, that's pretty much exactly it. So maybe a bit over a year ago or a year and a half ago now, we did a survey of .NET developers, over 1,000 developers, and more than 70% of them expressed interest in a big data solution. They wanted to be able to integrate big data directly into their major C# business logic or their existing C# or F# knowledge that they already have. But it would be really challenging or time consuming to go learn another language or to convert their millions of lines of business logic into Python or Scala or something like that. So we decided to create these C# and F# bindings to Apache Spark, which is now what's known as .NET for Apache Spark.
Okay, can you tell us how this works architecturally? For example, if you write some .NET queries, if that's what they're even called, for Apache Spark, do those run inside the database process? Do they run in their own separate process? And how does that relate to what those other programming languages would do? Is it the same?
Sure, yeah. So we designed the .NET bindings are on the Spark interop layer. So they have the same performance as other languages like Python or Scala. So you don't have to worry that .NET bindings are going to be less performant because they're just as performant, if not more so. And as for the architecture itself, so there's a few main components. They can be broken down pretty easily. So the main component is what's known as the driver or the driver program. And the driver consists of the C# or the F# code. So let's say you could have a C# console application where you have pre-existing business logic. And then you could write some code using the .NET for Apache Spark APIs, which would include a Spark session. Now, a Spark session is a component of Apache Spark that essentially takes the user's program. So it takes that C# console application and it divides it into smaller pieces. Now, those smaller pieces are known as tasks, and they get distributed among worker nodes or executors. And then essentially, the Spark session divides up the user's program. Little bits of that user's program each get executed by a worker node, and then the results of all those worker nodes get sent back to the driver.
Makes sense. So are you going to show us a demo today or some code that we can look at where we can start to see this in action?
Absolutely, yeah. I have a couple of coding demos, both locally and in the cloud, so we can really show some of the cool features and abilities of .NET for Spark.
Let's do it.
Okay, so I'll go ahead and share my screen and we can take a look at the first demo. Okay, so here we have our first demo that I'll take a run through here. So here we have Visual Studio, and I just created a simple C# console app, just standard .NET Core console app. And I've already installed the Microsoft Spark NuGet package, which gives us access to all of that awesome .NET for Apache Spark functionality. And when you add the Microsoft Spark NuGet package, you can see that you get a couple of jar files automatically added. And we can see that they have a few different numbers here. So the 2.3 or the 2.4 represents the version of Apache Spark that we're using, whereas the 0.10 represents the version of .NET for Apache Spark that we're using, or the version of the Microsoft Spark jar file. So in our case, we'll be able to run our application using either Apache Spark version 2.3 or 2.4, and using the Microsoft Spark NuGet package 0.10. So now to get into the actual code, this is just a really straightforward coding example to help us take a look at some GitHub projects data. So I have a CSV file containing some information about GitHub projects, including their URL, some committer information, when they were last forked from, how many times they've been forked from. And I'm curious to see, on average, how many times each language has been forked. So I want to see, on average, how many times have C# projects been forked, and Java projects been forked, and F# projects been forked, and so on. So if I scroll down here into my console app, I can see that in main here, I start off by establishing that Spark session, which is going to give us access to all of the Spark functionality and will be what is able to go ahead and divide our driver program. And I just went ahead and named my app GitHub and Spark Batch, because this is going to be an example of batch processing. Batch processing just means that we're analyzing data that's already been stored, so it's not being streamed or updated live. So after we've created a Spark session, we want to go ahead and start reading in our input data. So what we're going to go ahead and do is read it into what's known as a data frame. And a data frame is a really standard Spark object, and it's going to be the object we use to store any of our data that we're reading in. So in our case, we can create a new data frame. I just call it projects.df to stand for the projects data frame. And I go ahead and establish a schema for it. And a schema is going to be what represents the pattern of our data. So I know that the columns are going to include an ID, which is going to be an integer, a URL to our project, which is going to be a string, and so on. And then lastly, I can just call .csv, which means I'm going to be reading in a comma-separated values file. And I'll be passing in my CSV as an argument. So I just passed arg0 here. So now that we've gone ahead and created a Spark session and read our data into a data frame, we can just take a look at how our data appears. So we can do that by calling .show on our data frame. So before we get too much farther into the analysis of our data here, let's take a look at what the output would actually be from running this program so far. So luckily, I've already gone ahead and run our app just to save us a little bit of time. So in order to run it, what I did in a command prompt was I just changed into my directory of my app here. So the app is GitHub projects. And then I had done a .NET build just to go ahead and build my application. Since the build succeeded, I can go ahead and run my app. Now, when we run a console app containing .NET for Spark code, we use a command known as Spark Submit. Now, Spark Submit is consistent across different languages. Like if we were submitting a Scala app, we would use Spark Submit as well. So it's a standard way to deploy our Spark applications. And we can see there's a few components to our Spark Submit command. So it's always going to contain the .NET runner, which allows us to run .NET code with Spark. We include the path to the jar file we want to use. So that jar file that was listed in Visual Studio, I'm going to use the one that uses Apache Spark version 2.4. And then we can include any other sort of app details or files necessary for our application. So I can include the DLL for our app, and I can include project_smaller.csv, which is going to be that input file that stores all of our GitHub projects data. So after running Spark Submit, let's take a look at what we see from showing that data frame. So I'll scroll down here, and we can see, okay, so we have this output here. And we can see that it has all the columns that we had specifically named in the schema, so like ID and URL, and it has the data filled in here. But you may notice it's a little bit difficult to read. Like the columns kind of overlap, so the last couple of columns go over here, and then there's a lot of null and missing values. So this data doesn't really seem the easiest to understand or analyze. So next, what we're going to want to do is clean up this data. So we can go ahead and go back to Visual Studio to see what we do next in our application. So the next step that we'll typically want to do after reading in data is some sort of data prep or data preparation. And now data prep allows us to get cleaner looking data. So maybe we can remove some missing values or some extra values we don't need. So in our case, I decided to drop any rows with NA values so we don't have any sort of nulls. And then I also decided to remove some unnecessary columns so that when we perform later calculations, we're not performing calculations on extra data we really don't need, which could maybe slow us down or confuse things. So to find the average number of times each language has been forked from, we don't really need the ID, the URL, or the owner's ID of these projects. So I just went ahead and dropped those columns. Finally, I went ahead and called show so that we can see what our cleaned up data looks like. So I'm going to go back to the command prompt here, and let's see what our cleaned up data frame looks like. And we can see that this is a lot easier to understand, and it really does look like cleaned data. So we have fewer columns, and we don't have any sort of null or missing values. So now that we've prepared our data, let's go ahead and perform the calculation that we wanted. Let's find the average number of times each language has been forked. So what I'm going to do is, using my cleaned up data frame, I am going to first group by language. So group by allows us to group our data by any of the input columns. So in our case, I want to put all the languages into their own group. So all the C# projects are together, and all the F# projects are together, and so on. And then when we call group by, we can call aggregate or .agg on each of those groups, which allows us to provide or to apply some sort of functionality to each group. So in our case, we're going to find the average of the forked from column of each language, which is exactly what we wanted to do. And since I'm most interested in which languages have been forked from the most often, I just also went ahead and ordered my data in descending order. So I have those top forked from languages at the beginning of our data frame. And I called show so we can take a look at what our data actually looks like after those calculations. So let's reopen our command prompt here and scroll down. And here we can see we have one final data frame. So it has a language column and an average forked from column. And we can see here that we have some values and they are in descending order, which is exactly what we wanted. So that's really cool. We're able to find the average number of times each language has been forked in our input data.
Wow. Some of those languages I haven't even heard of, but looks cool. Could you give us a sense of how long this would have taken to have run if you had, done it live on the show?
Sure. So for the data that I'm working with right now, it's in the order of megabytes or a few gigabytes. So it took maybe 2 to 5 minutes to run locally on my machine. But I've also done some calculations very similar to these using 10 or 20 gigabytes of data scaled out to Azure, which I'll show coming up soon. And it was able to only take 5 to 7 minutes to analyze like 15 or 20 gigabytes of data.
I see. So it's the so this was obviously an interesting demo example, but would you say that it's representative of what you would imagine people are doing in the real world, or how would you speak to that?
I would say that the steps and the order of the steps is pretty representative of what you would do in the real world. So to go back to the code itself, you're always going to start off with creating a Spark session, since that's what actually introduces the Spark functionality. And then you pretty much always start reading in your data, whether you're doing batch processing like we did here, or working with data that's already been stored in a file, or if we were reading in 100 files, or if we were reading in streaming data, so data coming live from a sensor or from some sort of machine, we're always going to store it in a data frame or maybe a couple of data frames. And then typically it's also good practice to do some data prep or data cleanup so that you actually know what you're working with and you don't have some errors in your calculations later on.
Understood. So that part makes sense. I guess the other part of my question is, with the particular question you're asking, you have the answer now. The answer isn't going to change tomorrow. Like if you ran it tomorrow, you would get a very similar answer. So you could imagine the result of that data going into, a Word document or something like that, like in a report. Whereas other ones, you could imagine being a dashboard that might change day by day or even hour by hour. Can you speak to kind of the difference between those, or is that not fundamentally super important to the code that you would write?
I would say it's not necessarily fundamentally important to the specific code we would write. It would be fundamental to if you were building probably a big data pipeline. So a pipeline consists of the different steps like reading in your data and locating it, ingesting it, so you read it into maybe a data frame or a file of some sort, and then having code, and then running it at a certain cadence or from certain data sources. So I would say that would depend more on how often you're working with your data and the data source. So I don't think it would vary too much based on the content we actually wrote here.
Makes sense. I guess the other question is, could you imagine that you might have a program that, runs for longer, that keeps the data frame, for example, as more of an asset, and then continues to ask different questions to that data frame? And maybe I'm using slightly the wrong words, but like this is definitely batch. Like it does a set of things, gets the answer, and then it's like, okay, I'm done. Could you imagine one that ran for longer and you were able to ask more questions?
Yeah, I think so, definitely. I think that would come more into either using updated batches of data or using Spark structured streaming, which .NET for Apache Spark supports, where you have a stream of continuous data coming in, so maybe from a website or a server of some sort, and it essentially breaks that data down into micro batches, so it can process maybe the last 5 name inputs that were put in on a website, and then it can go and apply some calculations and output something to a screen or give us some sort of insights. And then the app will keep on running, and it'll keep processing those micro batches of streaming information.
Okay, so lots of options.
Yeah, for sure.
Okay, well, I think this is great for today. I suspect that there are a few other things that we could talk about, like maybe how you run this on Azure, for example, in a part 2. But I think as an overview, we definitely got the idea across.
Yeah.
So thanks for being on the show.
Yeah, thanks for having me. This was super fun, and I can't wait
Yeah,
for part two.
yeah, exactly. Okay, well, this has been another episode of the On.NET Show, and today we talked with Brigit about .NET for Apache Spark. Have fun.